So welcome to today's session. So we have already started with third chapter, that is data structures and operations. We have seen what data is, various ways of arrangement of data, how they are being classified, then what are the various operations. One of the arrangement is known as your stack, which following your LIFO principle, that is last in first out principle. And then we saw about the stack implementation, how it looks like and what are the operations that could be performed on a stack. So the operations are your pop and your push operations. So what are the various applications? Where are the various applications of stack we have seen? What is meant by a queue? That is also another arrangement of your data, which is following your first in first out principle. And then we saw the implementation, which has got your two ends, that is rear end and front end, through which the data or elements are given in and taken out. So the operations on the queue also we have seen. So the next what we saw was the application of a queue, and then from there we went on to circular queues. That is comparison between a linear queue and a circular queue also we have seen. And what are the advantages of using a circular queue by avoiding the disadvantages of your linear queue. So all these we have seen. Till this we have seen. Okay. So the next important topic that we are going to see is known as your linked list. The next important topic that we are going to see is known as your linked list. So linked list, that is, when we see, it is also a collection of data without any limit. Okay, linked list is also a collection of data without any limit. But when you compare it with your ordinary stacks and queues, it is actually a logical concept which has been implemented using your arrays. So what we have, the limitation there is the maximum size has to be given. അതായത് എത്രയാണ് maximum number of elements എന്നുള്ളത് we have to give. So this linked list is a good example for your dynamic data structure. Dynamic means what? At the time of execution only, you're going to decide whether you want to input any more data or just stop like that. Okay, if you want to add any more data like that, you are going to decide. So if needed, you will go on to add few more data, otherwise we will stop. So what is the size, all those is not predetermined. You will just only implement it at the time of execution. How much of data you want to include, you can include. But whereas you're in your stacks and queues, it is static. Why? Because the size, maximum എത്രയാണ് values എന്നുള്ളത്, you are already fixing it. Okay. Next is grows and shrinks when data is added and removed. Grows and shrinks. So ആവശ്യമുള്ളപ്പോൾ you can include your data. If not, you can stop it. Otherwise, you can remove the data whenever you want, from whichever position you want. Whenever you want and from whichever position. ഏതൊരു പൊസിഷനിലേക്ക് ഈ പർട്ടിക്കുലർ പൊസിഷനിൽ തന്നെ ഡേറ്റ വന്ന് ആഡ് ആവണം എന്നുള്ള ഒരു കമ്പൽഷനും ഇല്ല. ദാറ്റ് ഈസ് towards the ends മാത്രമേ you have to add the data എന്നുള്ള compulsion is not there. You can add the data even in the middle. You can also add the data even in the middle. Memory allocation is at execution time. Here memory is allocated in advance. Advance in the parayan reason is because the number of elements is going to be prefixed. That is, maximum number of elements you are estimating it in the beginning itself. Okay. Elements are scattered in the memory and are linked using address. If a stack and queue കാണുമ്പോൾ, okay, we have seen the rough diagrammatic representation of your stacks and queues. We have seen that the elements are placed one after the other. We have seen that the elements are placed one after the other. But whereas in linked list, it is not like that. In linked list, it is not like that. It is scattered here and there in the memory. എവിടെ വേണമെങ്കിലും ഉണ്ടാവും, but you are going to connect it. Now look into this diagram given below. Maybe this looks like as though arrangement കാണുമ്പോൾ you feel that it is arranged in a proper order, but exactly it is not like that. But exactly it is not like that. Even E diagrammatic one, where I'm drawing a square mark. Okay. ഈ diagram കാണുമ്പോൾ you may feel that it is placed one after the other. Okay, but exactly it is not like this. It is totally scattered here and there in the memory. Okay, so how all those only you are going to look upon in the operations on linked list. So a linked list na parayumbo, it is actually a collection of nodes. So here you can see this is a node, this is another node, this is node, each one is called as a node. Idil oronum nodes we call it. Okay, each one is called as the nodes. Now these nodes, can you see it is split into two halves? These nodes, can you see it is split into രണ്ട് segment ആയിട്ട് split ആയിട്ടുണ്ട് കണ്ടോ? Can you see each and every node? It is split into two segments. Split ആയിട്ടുണ്ടോ? Yes. One is part of the address and the other is data in it. One is address and the other is data in it. അപ്പൊ ഇങ്ങനെയാണ് it is being split into two parts. Okay. Where, now listen to this first one. Listen to this first one. Where this 25, this 25 is called as your data, and this round symbol is there now with an arrow mark here like this in golden color. That is known as your address. That is known as your address. Address nu parayanathu node 2. Node 2 undallo. Node 2 memory il evideyanu ullathu. Okay, where in which position is node 2 lying in the memory? That address is stored here in node 1. Node 1 le it stores the address of the next node. Okay, so oro node edukumbol next node inde address aanu it is going to be saved in the previous node. So for node 1 when I take, it stores the address of node 2. Node 2 memory il evide ulla vecha it will find out, and then address eduthu it will be stored in node 1. Okay, similarly node 2 eduthalo, here one yellow golden mark is there which shows the address of node 2. Here what happens is node 3 la address, node 3 la address will be stored in node 2. Node 3's address will be stored in node 2. Like this it goes on correspondingly. Like this it goes on correspondingly. As and when required, you can go on to add the elements even in the middle. You can go on to add the elements even in the middle. Middle evada venengilum you can go on to add the elements. Appo ivadeyum avam, in between ivadeyum avam, ivadeyum, or here or here, e gap, or at the last also, or at the last also. At any point you can go on to add the elements. The last node contains a null pointer which indicates that no more nodes to be added. Appo last node എങ്ങനെയാണ് നമ്മൾ find out ചെയ്യുക? Appo node you will not have the address of the next element. You will not have the address of the next element. Instead you will have it as a null pointer. Instead you will have it as a null pointer which indicates that this is the end of your linked list. Which indicates that this is the end of your linked list. Okay, so just on a view you may feel that this is placed one after the other, but exactly it is not like this. It is scattered and placed here and there. Okay, and next node the address is stored in the previous node. The next node's address is stored in the previous node. So based on this only you are going to study about some operations on linked list. Based on this you will learn about some operations on linked list. So what are the various operations? So implementation. First this list has to be created. First this list has to be created. How you are going to create? How you are going to create? So first what I have done is struct node, a structure I am creating. Inside that I have two variables, int data and node star link. Node star link. So node, your new structure becomes the structure name becomes your new data type. Your structure name becomes your new data type. Appo aa node le thanne you are going to give a link. Aa node le thanne you are going to give a link. So what happens is it will automatically start creating a linked list. It will automatically start creating a linked list. So node means the name of the structure, data means element, link means the address. Link means the address. So now look into the diagrammatic representation and the syntax. For a small example is given. Okay. So start node we know. Okay. Evideയാണ് linked list start ചെയ്യേണ്ടത് we know. So assume that to be 2000. We are assuming it to be 2000. Sorry, 1000. We are assuming it to be in 1000. So the next data, character data of 10. Character data of 10. Which means some data has to be given over there, which is a character array. Some data has to be given over there, which is a character array. Okay. And so what happens, where it is placed and all we have to see. So again, in that structure itself, you have a node star link, node star link. Upper, we know that start or particular point we are starting. The address is there. And the address is there. What is that? Or node we are creating here. Can you see this? We are creating a node here. What is this? Sonu, a data is entered over there. Sonu, a data is entered over there. The address, can you see here as 1000? Can you see here as 1000? This 1000 is stored in this start position. This address value 1000 is stored in the start position. E 1000 ennallathu is stored over here. Okay. So like that, you will go on to create as many nodes as possible. Up next node created. Okay, next node you will create in this pattern. Up what is the, where is the address being stored? For example, it is 1200. Our address value is copied over here. That address value is copied over here. So this creates a link. This creates a link. Up idu rendum thammilu oru link create ആയി. So similarly, like this, we will go on to create until we stop. In where oru idu illengil, this we have to construct with proper logics. Only then we can create a put a termination. Proper logics ഉണ്ടെങ്കിൽ മാത്രമേ we can put a termination. So adinu proper logic means we have to go on with the loop structure. We can go on with the loop structure. Appo last there are no more values, no more ini where oru data enter cheyyanda engil what we do is in that place we will fill it with the null character. Appo in that place oru checking condition endengilum undavana. Okay, some checking condition has to be given to indicate that we have reached towards the end of the linked list. To indicate that we have reached towards the end of the linked list. Like this, we will go on to create a linked list. Like this, we will go on to create a linked list. Is this part clear now? So the next one is creation of a linked list. Appo ee creation il there are two different ways. Adayathu start position empty aano anganeyum create cheyam allengil start position അറിഞ്ഞും കൊണ്ടും create ചെയ്യാം. There are two different ways of creating. One is knowing your assuming that to be an empty linked list, and one which is has some values anganeyum pogam. Okay, so creation of linked list. So create a node containing, create a node and obtain its address. Create a node and obtain its address. അപ്പൊ ആദ്യം ഒരു node create ചെയ്യാം. Listen, the first node, can you see over here? Wherever I put an arrow mark, just have a note over those positions, okay? Can you see over here? This is the first node that is created. What happens? You are going to enter the data that is 25. You are going to enter the data that is 25. Okay. First node is created and data and link are filled. Link avada fill cheyyanam. So what is that value ennullathu? Next you have to fill it over there. How you are going to fill that link part over there? So for that, what you keep doing is, or in your node create it. Here you will go on to create another node. Here you will go on to create another node. That's where edo or position lana. See, it is lying in some other position known as 2000. It is lying in some other position known as 2000. Now start ennu parayanathu is a temporary node. Start ennu parayanathu is a temporary node. Appo adiliki this address is copied over there. Adiliki this address is copied over there. And that address will be placed over here. And that address will be placed over here. Appo like that only you are going to create a link. Like this only you are going to create a link. Appo oro pravashyam you will go on to create a node. Adinte address find out cheyum. Adu or start node lu vekkum. എന്നിട്ട് you will copy that address to the previous node. Previous node, where do you copy it? In the link part. In the link part, adinte address eduthu copy cheyidu vekkum. So previous nodes, you will go on to keep the post the address over there. Adayithu fill cheyidu vekkum. Appo anganeyanu you are going to get the links. Anganeyanu you are going to get the links. Now see here, this the second node is created. Data and links are filled. Up data 34 I എന്നിട്ട് and the address you will go on to fill it over here. Up first see, up first second tamilu or link create. Can you see the link created between the first and second? Up the first one data is 25. Up the start value is 2000. Other start node lu koduthu kazhinju. Next, the next node every create it is in 2300. Up the 2300 value, 2300 in the value is passed over here. Okay, the value is passed over here. Like this, you have created a link. Up it 34 and the value is there. Up automatically it will end up with a null value. ഇനി അടുത്തത് ഒരു പുതിയ node. See, next you are going to create a third node, that is its value is its memory is in the location known as 3000. And data you have given it as 17. Data you have given it as 17. Now can you see the link of all the three nodes? Here you can see the link of all the three nodes. First one 25 and the value. Second one, the value it is in 2300, that is linked over here. Third up and the data is put in this position. Then the third one is 3000. Other the address is 3000, that is given in the second node. You have created a connection. Okay. Then the next one is, and the third one the value is 17 that you have entered. One more new node if you want to create, you have to follow the same procedure. You have to follow the same procedure once again. You will go on to create some more, as many number of nodes until you give a value known as null in the last node. Until you give a value known as null in the last node, you can go on to add values into the linked list. You can go on to increase the size of your linked list. Is this clear? So this is how you will create a linked list.